Okay, another item on our agenda today is a new presentation and a set of topics. If we go to the outline, this is going to be the presentation that follows the presentations on paths, files, and directories. So I'm just going to close this one for now. Okay, and open this presentation, and this is going to be concerning processing of the text files. So of course text files are extremely widespread. This is the friendliest format for you to work with, because it's a very standard way of both reading and writing those files. So this is our topic of our discussion. So it has some 20 or so points to talk about, and we begin by looking at this picture. Okay, this is Java input-output hierarchy with various types of objects, and I think it's pretty overwhelming. I just would like to tell you that the upper portion of this is designed to work with binary files and raw file formats, whereas the bottom portion of this hierarchy for files actually is designed to work with text files. There's random files sitting here somewhere in between, but the classes that exist in this hierarchy down here are going to be those classes that we're going to be talking about with respect to text files. So I like to separate basically the discussion of text file processing and binary file processing and random access file processing, because they all have their own specific important features, and those are, generally speaking, separate areas in which you can go when working with files. So I'm just going to copy this image and go to my Scratchpad here and simply paste it, right? So just paste it, and guess what? Since I'm not planning to cover this upper portion, I'm just going to kind of scroll this up and work with the bottom portion of this view. Okay, and I can even make it even lighter by removing classes that I don't need. All right, so just these that I do need will remain, and we will essentially use this as a Scratchpad to maybe do some annotations and have some conversation about these classes. So this is the bottom portion of the chart that displays the hierarchy of Java file access library, and like I said, today's topic is going to be, generally speaking, text files. Okay, text files, plain text files, which only contain readable characters. So that's going to be our focus. So this presentation here, this is the first slide, and we will follow. So we're just going to explore various ways to store information in a text file and load information from the text file, and see what things exist that we can use. I do have links to this website, which I found a few years ago, and I find those class diagrams basically showing the various Java classes to be very helpful, because it gives you a quick look at what methods are available within those classes. But of course we need to discuss this at the high level first, so that then we can go and look at some specifics. But generally speaking, we need to essentially discuss the role of individual classes in this hierarchy, and then make use of them in the form of practical examples. So Generally speaking, the first thing that we're about to discuss is this buffered writer, right? So once again, if I switch to my picture, the buffered writer is essentially the class which is located, right? So it's this class that we're trying to discuss right here, right? So buffered writer, it's the one that we're trying to discuss first, and what we say about the buffered writer, that it implements buffered output of character streams. Okay, so we need to have a character stream, and once we have the character stream, buffered writer will allow us to actually write these character streams into a file. Print writer is just another one which adds character formatting for primitive types and strings. Remember how system.out and system.in were helpful when we were trying to work with the console and the keyboard? Print writer is going to behave in a very similar manner, and again, if you look at this, print writer is this class right here, which we're going to discuss today. Okay, file writer implements low-level writing of character files. So character files or text files or plain text files, these are all references to this specific type of files that contain only readable characters, no control characters, or generally speaking, no binary data. So those are human-friendly, plain text files. All right, so the file writer on this hierarchy is located right here, okay? So the file writer actually derives itself from the output stream writer, which we also mentioned during our discussion. But so far, we're going to be focusing on these three. And once we have those three, let's take a look at this example. I'm not planning to copy and paste many of these samples into our source file to compile and try this, but look what happens. Basically, we're trying to do something about this character output, right? So what we'd like to do is we'd like to, as before, when we use print line statement working with the console, we'd like to utilize everything we already know about print line statement, which was very helpful when we were working with console applications, to write plain text into the file. So obviously we have a string here which has a couple of tabs embedded in the text, like \T and another \T essentially represent embedded tabs. So embedded tabs would allow us to create a tab delimited string. But what is happening here is that we're trying to send this string of characters into a file. So how is this done? Well, first of all, this is plain text, right? Those are not binary characters. They're just normal, normal readable white space, including tabs and spaces, and printable characters. So what we do first, we take this books file object, which happens to be the file. So observe how many classes are involved in order in this specific sample, right? In order for it to store this text in a file. Number one, we go to paths, right? We go to paths and we say, give us the path, and we specify the text version of the path. So this returns back a path. Once you have the path, you can convert it into a file, and what gets back is a file object. And this file object is books file. So remember, this books file object, object reference to be more specific, refers to that object that represents and encapsulates the metadata about the file. So this is not an object that you can simply open and say read information. This is just an object that encapsulates the metadata. But once we have the metadata, we pass this metadata to the file writer, okay? So we said about the file writer that this is the file writer is the class responsible for giving us access to facilities that can work with the character file or text file, okay? So the file writer is created as new. So we create an object and give it, on this line, we give it a file object, which we have already constructed. Then we also want to use buffered writer, okay? And the buffered writer is the one that we already mentioned. It's basically the buffered, unbuffered I/O we're going to discuss just in a few minutes. This is a very interesting topic, but generally speaking, anytime you can, you want to have a buffered input-output processing. An alternative to the buffered input-output processing is unbuffered or raw or direct, which means that read and write information in and out of files as soon as possible. Don't temporarily buffer that information anywhere. This is usually going to degrade the performance. Buffered I/O improves the performance in a huge way. So that's why, for now, just briefly speaking, we want to use this buffered writer, and we also create it. Now, if you observe the structure of these parentheses, the way the parameters are passed, buffered writer takes file writer as a parameter, right? A file writer object which we create, it takes as a parameter. And finally, the result of this, the buffered writer, is passed as a parameter to the print writer, which then gives us this all familiar print line interface. All right, okay, so we construct this print writer, and guess what? The print writer, when constructed in this manner, it instantly opens the file for writing. Okay, so we don't have to have a separate statement of any kind to say open file. It will open the file, and it will actually also create the file if it doesn't exist. And of course, we discussed earlier on that it's a great idea to close the file, because closing the file can be, explicitly closing the file is important because it frees the system resources which are associated with that file, and also many system errors also can occur here. So exceptions can be thrown at this stage, and closing the file, generally speaking, will be the final statement that you need to execute with respect to a file. Of course, this type of thing, like this print writer, as you can see, print writer is a helper object, a stream-like helper object, which encapsulates the buffered writer, the file writer, and also, of course, it encapsulates the file metadata, which was originally constructed from the path that we were able to obtain. Okay, so we say print line, and for all of this to happen, all of this, of course, we need to use the try and catch block, which prevents, from compiler errors, because there are some checked errors, and you can research more in terms of what specific errors or exceptions you can get. But what I'm doing here is just generically say input-output exception, something failed, and I'm printing what that exception is. Of course, another helpful thing would be to print the stack trace of that exception. But this is what it takes to construct a class named text output demo. Okay, so text output demo involves all of this work, and the outcome of this is that we create the file and we write into that file. Now also notice that if we execute this program multiple times, the information into the file is written at the beginning of the file. Okay, so perhaps this may be a good, good thing to try to try this code in our sample, is that we can try this a couple of times. Okay, so I have this path, and I will basically use this code here to so let me just format my source. Okay, right there. Okay, first of all, let's fix imports if we're missing any of the imports. So let's use this directory string, okay, and use this directory string and say plus path to this file. See how I'm using the / directory string to construct this. Then I seem to have introduced an extra brace here. So once again, format. Okay, so that looks better. Let me just build this just to see if I have any errors. Illegal start of expression. Get rid of this, right? I mean, why do I need two main? I don't need that. Okay, so once again, so I'm just what I'll be doing here is that the first time it's going to store, allegedly is going to use this data subdirectory, create file name dummy.txt, and write information into it, right? So if everything goes well, the file will be closed, and this is an older portion of our application. So let's run this. Okay, see how now we list the dummy.txt. Let's take a look at dummy.txt and inside the data right here. Here it is, book. You know, we have this information stored. But I'd like to show you that. That when you use this print writer, what happens is that if I change this, right? If I just change it to say C++ programming, okay, and change that. This is now a shorter string, okay, and I will run this again, but this time the file already existed. So if I open this file, okay, see how basically the old text got replaced, just got replaced by new text. So print line, the way it's written right now, what we do is, in this sample, just realize that it does not append. It does not append the information to the file. It simply just goes in and starts writing from the beginning of the file. Okay, so let's do this like 3 times in a row, okay, or 4 times in a row. I run it again, take a look at this file again, and the content of this file, of course, is this. But if I now go and change it the way it was before, right, say go back to a single line, okay, and just say it was saying beginning Java programming, and if I run this again and take a look at the content of my file, you see what happened? The content of the file got entirely truncated. The file was wiped off, the content is gone, and the file was written as new. This is the behavior of your print writer, and this is what this specific set of options that we've used is doing when you use this combination of file writer, buffer writer, and print writer when you construct it. So we will explore other possibilities to perhaps append information to the file, not necessarily wipe off the old information and replace it with new. So let's move on. Okay, and